All right, so today we're going to learn about DeMoivres Theorem. And what happens with DeMoivres Theorem is we are taking a polar, as you guys can see right there with your r times cosine theta plus I sine theta, and that's being taken to an exponent. Now, something that I really just want you to process through when it comes to exponents, I'm going to go over here off to the side. If I were taking something like 2, and I'm going to shorten this up, times cis of 30, and all of that was being squared. Remember, anytime you're taking something to an exponent, that means you are multiplying that thing by itself however many times that exponent says. So this essentially, you guys, would become 2 times, or cis 30 is being multiplied again by 2 cis 30. So what we learned yesterday with multiplying polars is that we would multiply our r's. 2 times 2 is 4, and we would add our thetas, and we would end up getting cis of 60. Now, what I want you guys to see with those numbers is that if I were to take this exponent of 2, and I somehow need to use the radius of 2 and the exponent of 2 to get a 4, we're going to see that we have 2 taken to the second power. I know that some of you would say, well, just multiply them. And if I had done this to a power of 3, you would have seen that a little bit more obvious. But your rule when it comes to powers of complex numbers is that what you're going to do is you're going to take your r to whatever that nth power is. Okay, so r is being taken to that nth power. So we did 2 to the second power is equal to 4. Now, if we look at, we started out with a angle of 30 degrees and we ended with an angle of 60 degrees, and we had it to the power of 2, well, there's only one way for us to use the number 2 and 30 and get a 60, and that is to multiply them. So that is our next property. 2 times 30 was 60, and I'll highlight that there. So I used that exponent of 2, I used that theta of 30, and I multiplied those numbers to get 60. So our next property says that we're going to take your r to the nth, and this will be multiplied by your cosine, and your theta is going to be multiplied by that exponent for both sine and cosine. So your r's get taken to the power, and your thetas get multiplied. Now, one thing that you need to understand about DeMoivres is that you cannot apply that if it is written in rectangular form. You have to do this in polar form. So you might get to some questions as you guys can kind of glance down quickly on these notes. Your first 2 examples that I'm going to walk you through are in polar. Your second 2 examples are actually written in rectangular. So we're going to have to switch to polar, do the DeMoivres, then, because it says express each answer in rectangular, we're going to have to convert back into rectangular. So we've got a lot of work ahead of us. So let's zoom in. Let's do the nice ones first. These first 2 examples, they say express the answer in polar form, which means leave it in your r cis theta. Or you can go ahead and write that totally out. That would be r times cosine theta plus I sine theta. Whatever makes you more comfortable. It does not matter. They actively mean the exact same thing. So what we're going to do here, and what I showed you up above in that DeMoivres theorem, is we're going to take this radius that was given, and we're going to take that to the exponent of 4. So your radius gets taken to that exponent. Once we do 2 to the 4th, this comes out as 16. So we'll simplify it there. And now that's being multiplied by cosine of pi over 3. That's my original theta. My original theta is being multiplied by 4 for both cosine and sine. So I will get a final answer of 16 as my radius, and cosine of 4/3 pi plus I sine of 4/3 pi. Now, because this said leave your answer in polar form, just go ahead and leave it exactly the way that you guys see it. And if we started you in radians, leave your answer in radians. Don't convert that into 240 degrees for me. Just leave that alone. Call this your final answer right here. Okay, so we'll do one more off to the right, same idea. We're going to take that radius to the 6th power. That r is being taken to the power of 6. This is going to be multiplied through by cosine of pi over 4 is being multiplied through by 6. And I have my I times sine pi over 4 times 6. 4 to the 6th power is 4,096. And cosine of 6 pi over 4, I am going to go ahead and reduce that to my 3 pi over 2. Now, if I asked you to switch that into rectangular, hopefully you see 3 pi over 2. That is your negative y-axis. So those would be really nice quadrantals to work with. Okay, so here are the problems where we start to have a little bit more work ahead of us. They want us to leave our answer in rectangular. Not only do they start us in rectangular, so our very first job is to convert to polar. I cannot apply DeMoivres when it is in rectangular form. So here's what I do off to the side. I kind of sketch my picture. I see my x was positive square root 3. I see my y was a negative 1. I know that triangle very well. I know that this triangle would have a hypotenuse of 2, a little reference angle in there of 30, but that's not actually my angle. Remember, your theta is that angle that gets you to the terminal side in that quadrant 4. So I know this one. This one does not require me to use Pythagorean theorem. This one does not require me to use my SOHCAHTOA. I know this triangle, so I'm going to keep it as simple as that. What I see is that my r value is 2, and my theta was 330. Now, something that students forget all the time each year is the fact that, you guys, I haven't done anything with that exponent. All I did was I took that rectangular and I converted it into that polar. I still need to deal with that exponent. That exponent did not go away. But once it's in polar, then I can go ahead and second step is I can apply my DeMoivres, which means my r gets taken to that power and my theta gets multiplied. So I have it 2 to the 6th is at 64. I have now cis, cosine plus I sine, 330 is being multiplied by 6. This is 1,980. Now, the next step after that would be to go ahead and convert back to rectangular. So if I need to convert this back to rectangular, I'm going to be real. I have no idea where 1,980 is. So I'm going to go ahead and I'm going to keep subtracting my 360 all the way until I have something to work with that makes my life a whole lot easier. And as I continue to subtract 360, just going through, the first time was 1620, then 1260, subtract another 360 again, 900, then it was 540, then it became 180. So I'm going to stop there, 64, cis, 180. Now, I love that 180. That tells me this is really 64 times the cosine of 180 plus I times the sine of 180. And I know these values. I have my quadrantals. So I'm going to go ahead and I'm going to evaluate the cosine of 180. So this is going to become 64 times the cosine of 180 is -1 plus I times the sine of 180. Sine of 180 is 0. Once I distribute that 64 into both, this is going to end up at -64. And that, my friends, is your final rectangular answer. And don't worry, I'm still here. I'm just giving a little bit of wait time for you guys to catch up with your writing things down. And this will be available on YouTube. So if I am walking through this a little bit too fast for you guys, please, and the link will be on Schoology, please feel free to go back and watch it as many times as you possibly need to. All right, so let's go to that next example. We've got 1 plus I root 3 all being taken to that 8th power. So again, I cannot apply that DeMoivres when it's written in rectangular. My first job is I need to convert to polar. So I'm going to focus in on this inside right here. I'm not even going to worry about that exponent, not yet anyway. So if I pick out my x movement and my y movement, I see that my x is a movement of 1, my y is a movement of square root 3. Again, this is a triangle, I know. I do not need to use Pythagorean theorem, but if you guys do, go ahead. I don't actually need to do inverse tangent because, again, I know this triangle. But if you don't recognize it, please feel free. Use your inverse tangent in order to do your opposite over adjacent. Use your Pythagorean theorem. But I know right away that this is 2 times the cosine of 60 plus my I times sine of 60. This is 2 cis 60. Now again, keep in mind I have not done anything with that exponent, so I need to make sure that I remember that that exponent still exists. So my second step is going to be to apply my DeMoivres. So I have 2 to the 8th times the cosine of 60 times 8. And 2 to the 8th is 256. I have a cosine now of 480 plus I sine of 480. And again, I'm going to go ahead and reduce that because my third step is I'm going to try to get it back into rectangular because that's what the directions said. So convert to rectangular. So we've got 480 is, I'm subtracting out 360. This gets me 256 because I'm doing coterminal. For those of you who forgot, 480 is too big, so I subtracted 360. This would be 256 times the cosine of 120 plus I times the sine of 120. So if you guys recall on Friday, I said maybe it's easier for you guys just to evaluate these numbers on the inside and then distribute the 256 in first. So that's the route that I'm going to take. 120 is in quadrant 2. It is a 60-degree reference angle. Across from 60 is square root 3. The adjacent side is -1. Hypotenuse is 2. The cosine of 120 is -1/2. And the sine of 120 is square root 3 over 2. I still have my i's in there. And I still have 256 out there on the outside. So when I multiply 256 times that -1/2, I get a final answer for the x of -128 plus I, and I'm going to move this I around a little bit because I know that I'm also going to have 128 as a whole number. We like to write our whole numbers before the variable. So 128I square root 3. That would be my final answer in rectangular after I distribute that 256 in. All right, so here we go. Last example of the day. Right now, already written in polar, so I don't have to do that conversion yet. I do need to switch this back to rectangular, but I can go ahead and start my work with just this 2 to the 5th multiplied by cosine of 210 times 5 plus I times the sine of 210 times 5. 2 to the 5th is 32 times the cosine of 210 multiplied through by 5 gives me 1050. I'll deal with coterminals here in a moment. Times sine of 1050. I'm going to do coterminal, so I'm going to subtract 360 from 1050. 1050 minus 360 is 690. I'm going to subtract 360 again. That puts me at 330. So the coterminal is 32 times the cosine of 330 plus I times the sine of 330. And again, just like the prior problem, I'm going to go ahead and draw myself a picture. I'm going to evaluate these inside numbers. I know how to do that. That's something that I've been working on for a while. We've been doing that for multiple months. 330 gives me a reference angle of 30, so I'm going to fill in my triangle the way that I know it. Cosine of 330 is square root 3 over 2. And sine of 330 is negative 1/2. So I'm going to keep that as negative I over 2. Distribute that 32 in, and I will get 16 square root 3 minus 16I. And that would be my final answer. I'll give you guys a moment to get caught up on writing. So again, this video will be available on Schoology. Please feel free to rewatch it. That's the end of our notes for today. So what I would like you guys to do is flip the page in your packet. You've got worksheet 8.4. It is pages 16 and 17. So go ahead, work on some of those. I do want to draw your attention. You can see them here on the screen. Questions 8, 9, 10, and 11 definitely require you to follow some order of operations. And something I want to remind you of is when you're working with some fractions, you need to remember that your numerator needs to be fully simplified before you would do any division, okay? So order of operations, exponents come first before multiplication. So follow those order of operations, simplify your numerator, simplify your denominator, then do your division. Or apply your DeMoivres, then multiply, but exponents come first. Watch that order of operation. Have a great day.